Welcome to the Norwegian Smart Grid Center's webinar series. The Smart Grid Center is a member organization for R&D institutions, companies, organizations, and public entities that aim to promote the implementation of smart solutions in the power system. The Smart Grid Center brings together members from across the power industry for a collective effort in research, innovation, and knowledge sharing, leading to a more flexible and intelligent power system. My name is Svein Erik Thorsen, and I am the Innovation Manager at the Norwegian Smart Grid Center. Our guest today is Jerome Garrison, Sales Manager in Europe, UK, Ireland, South America at DNV, and he will introduce Smart Cable Guard. Smart Cable Guard SCG is a state-of-the-art online time cable monitoring platform that enhances the reliability of medium voltage power distribution networks. It uses sensors and machine learning algorithms to detect and locate weak spots and potential faults in real time, preventing over 70% of cable-related outages. SCG provides power grid operators with real-time data for proactive maintenance, optimizing budget and resource use, and improving safety by reducing emergency repairs. Widely adopted by utilities worldwide, SCG has proven to significantly reduce power outage frequency and duration, offering an excellent return on investment. I would like to inform you that you can write your questions in the Q&A section above, and we will answer them shortly after the presentation. And with that, I present to you Jerome Garrison.
Thank you, Svein, for the introduction. I mean, it's good. I mean, I don't have to say anything more. You already mentioned a good amount of information about what Smart Cable Guard is. I will share my screen and I'll share my presentation. I have a couple of slides I would like to share. My name is Jeroen Gerritsen. I work at DNV in the Netherlands. I'm Dutch. And I've been working in the energy transition domain for the last 20 years in different roles, but mainly really focused on delivering smart solutions for the energy grid. I work for utility companies, for vendors, and now for DNV since this year. I would like to just share a little bit about DNV. You probably already know DNV, but I'll just have one slide on that, and then go into some of the trends and implications I see and solutions within the energy domain. And I'll go into what smart sensors can do and do for utilities. And I'll talk a little bit about our solution, the Smart Cable Guard. And I have two customer cases I would like to show to see, how we implement these kind of solutions with our customers. I'll do a short recap and then we'll open the floor for some questions. DNV, we're already 160 years here, about 15,000 employees and working all around the world in more than 100 countries with over 100,000 customers. And, we really focused on the energy transition and everything that's happening in this energy domain. We invest a lot of money into gaining experience and knowledge in this domain. We really work around the whole chain within the energy transition. So really from power system planning, transmission, distribution, technology, asset management, and then some of these digital solutions that we can provide. So really going from design to assets and storage, but also delivering support and in processing, calculation, and modeling, and analyzing and decision making within the utility domain, energy domain. I mean, I don't have to tell you, that this energy landscape is changing fast. I mean, global electricity demand, will double in the coming years. And also we'll have a lot more of these renewables coming into the grid, wind and solar, rising up to more than 70% of what we're actually going to use in electricity. So this decarbonization process is really moving ahead, and then by 2050 we'll probably have something like 90% of that done. But this means that there will be some really big challenges in how to manage that energy flow and energy mix within the grid. So we're seeing that there will be large investments being made. I mean, if you look at Europe alone, more than 500 billion euros will be spent until 2030, just to enhance our grid to make all these developments possible. One of the things that we do within DNV is we create this, what we call Energy Transition Outlook. And every year we create this report where we really look at these developments and really look at the impact and implications of that. It's a really interesting report. We use our own knowledge and experience, but also do a lot of these surveys with our customers and in the energy domain to really create this comprehensive report. I'll share this presentation with you later, and in that you'll find a link where you can download this report. These changes, within the energy landscape are really, affecting the modern utility. This energy landscape is changing, and the stakeholders are changing, and the position and role of the traditional utility is changing, playing a more active role in this whole flexible distributed energy resource management. And I think the modern utility will be more focused on its users or prosumers, create flexibility around that, and creating different market design and system operation design, but also different business models in really integrating all of these new ways of how we manage the grid. I think one of the main things I see changing in these utilities the last couple of years is the way they maintain and manage their assets, going more from a run to fail kind of mindset and reactive to a more proactive condition-based maintenance approach, where they have to find a kind of optimum between preventive maintenance and reactive maintenance, and really managing costs, but also really understanding actual status of the grid. I think that's how the modern utility will build these kind of system of systems where they integrate different types of data and formats to really understand what the actual status of their grid is, and then creating these these models and digital twins to then being able to simulate actual status, but also future state of the grid, to really get more control and gain and drive this kind of data-driven decision making. I mean, I think it's clear that for most utilities, waiting for something to happen is not anymore a strategy. It's really becoming a more proactive approach to really understanding what the status of the grid is, and then how to manage that and to plan new investments and changes. One of the things that I see frequently in these utilities, in this changing landscape, is that there is a kind of integration needed, right, between these two different worlds. One of them the IT world, and the other one the OT world. And that's actually quite challenging as I see it. It's two different groups of people speaking a different type of language, different types of education, different types of worlds coming together. One that really is more on the OT side, which talks about connected products, edge control, and sometimes about a kind of top layer where there is some kind of control or apps and analytics. And on the other side, on the IT side, they talk about systems of record, system of engagement, or system of intelligence or insight. And these are different worlds. These are different people, but also the dynamics within these worlds is different. If you look at life cycle management within the products and systems they use, it's very different. So, but what I see is that the successful utilities are really able to integrate these two parts of their organization. And some of them, they started to create these kind of data hubs where they could integrate all these data. They use a common data repository, but they also use, open standards and SIM-based models. And the ability to integrate different types of data in different locations within these organizations. And then being able to enhance that data, right, and do analytics on it and visualize it so that they can share it among them, the people in the different parts of the organization. So I have seen some really good examples in Norway as well, with LVI and with others where these kind of systems already have been developed and are really actually paying off in the modern utility. Another aspect, of doing all this is creating a secure system, right? Secured access to content, but also to system capabilities. Really creating a way of identifying users in a secure way, and then also having capabilities for these people in a kind of framework, right? A kind of security framework where you have user accounts, types, privileges and roles, and also permissions. And, this is just, trying to understand the world we're in and trying to see all these challenges that we are facing nowadays. And this is also how we at DNV look at, developing a solution for that. And one of these solutions is called Smart Cable Card. I want to go just a little bit into that, just to show what we are doing within DNV and how we have developed a solution for that. So we call it the Smart Cable Guard, and this is what we call a digital platform that detects weak spots and detects faults and locations of faults. And this is really made for underground infrastructure, so cables up to 70 kV. So we use hardware like sensors and field processing, and we use software or analytics to analyze the data and then do a kind of advising or monitoring for our customers, and really giving them support in how to manage the actual status of their cables. If you look at the modus of operation, we use two sensors on both sides of the cable and the control unit, who then communicates the data to our Smart Cable Guard platform. Actually, we do two things, right? One is we can detect any type of fault, permanent fault on that cable that we are monitoring. As we're using two sensors, we do two things. We measure the partial discharge inside of the cable, and we do that by inserting a pulse into the cable from both sides of both sides. So both sensors, we inject a pulse that runs through the cable that detects if there is a fault current, a fault happening on the cable. So we can really precisely know that there is a fault, but also detect the location of the fault. The second aspect that we measure is the development of partial discharge inside the cable. And as you know, partial discharge is a very good indicator for, degradation of the cable and its isolation. So this can really detect weak spots and can prevent faults, because by detecting these kind of issues, you can start really engaging into a condition-based maintenance approach. Just a little bit of background on how this started. We started more than 20 years ago in a kind of consortium together with some of our utilities in the Netherlands, and looking at is partial discharge a feasible way of really trying to understand the actual status within the cable. And within 10 years we started to develop a first product, and we launched that with one of our launching customers, Alliander in the Netherlands. And from there we started developing the solution and system But also, the way we analyze this data. There's a lot of intelligence and machine learning and AI that we incorporated into this solution to better understand the behavior of parcel discharge cables. So we started with Alliander as one of our, but we have now many of these other utilities all around the world. And our vision really is to really create a kind of platform for total grid monitoring. So not only for cables, but also for other assets that are in the grid. At this moment, there's more than 3,000 systems that we have installed all around the world. We're monitoring about 8,000 kilometers of cables, and we're doing that with over 50 customers all around the world. What we've seen is that we've prevented more than 300 of these failures of cables. And we really try to do this in a very secure way. So we do annual security testing on our system, both hardware and software, to ensure that these kind of systems, these IoT systems, are really being used in the best way possible. Just a short overview of where we're at, different DSOs, but also in transport or critical infrastructure. This can be large industries, but also in wind, for example. We have some big projects with large wind farms, one in Chile, for example, in an 800 megawatt wind park. Most of the value that comes from this system is really about monitoring, right? It's really about understanding actual status of that asset. And we do that by measuring PD in time. So what we see is that we can see developments of this PD in time, which really gives insight in, is this an asset that needs to be replaced? Is this an asset that maybe can extend the lifetime beyond its initial lifetime prediction, right? So it works in many ways in ensuring that you understand how to manage your assets and really in a data-driven way. We've made the system as open as we can, meaning that we use open standards and APIs to then leverage data coming from the system into the customer's system. And as I showed earlier, I think this is one of the essential parts of enhancing the energy transition by making data available and making data shareable in different parts of the organization so that it can be used to enhance and analyze it in the best way possible, depending on the business requirements. Just wanted to share shortly two use cases that we have. One is with Stedin, which is a utility in the Netherlands, and we have installed systems there. And at some point, we started seeing what we call a level 2 warning on a joint. What they did is they replaced this joint, and what we saw in our system that once the joint was replaced, the parcel discharge disappeared on that cable. So we knew that changing the joint was actually the issue of that problem. They then sent us the joint for investigation. We have a lab where we do these investigations, so we started to investigate this joint, and we saw very clear signs of parcel discharge. If you look at the picture on the lower right side, you see a kind of, it's almost 1 centimeter parcel discharge, which was seen on the cable. So this cable was, was going to be damaged at some point and blow up at some point because isolation was really minimal and a short circuit was about to happen. So they were able to detect the parcel discharge, replace the joint, and see that actually it was the joint that was damaged and was about to blow up. So they were really, in this way, they were able to ensure and close this cycle of detecting, exchanging, and then seeing that, okay, they prevented actually a fault. And this process, it is really important, and we work very closely with our customers to make sure that they reintegrate this kind of thinking, this more proactive way of thinking and managing the grid, so that they really have the benefits of monitoring in general. Another use case is with Alliander, where we have over 2,000 systems installed, and they are monitoring more than 6,000 kilometers of their grid. And in the years from 2017 on, they've prevented 200 of these cable failures by using this system. And they're really enthusiastic about this, and they've done a complete integration of this in their system, a fully integration into their SCADA. So if there's any fault, they will use Smart Cable Guard to detect the fault together with their fault pressure indicators and protection system, and then really use it for the detection of location. And this really helps them in minimizing their safety and outage time. Just to recap, like I mentioned, energy landscape changing rapidly. I mean, I think data decision making is essential to really drive this energy transition, and the collaboration between OT and IT, I think, is crucial in this. But it will need a modern IT architecture, and IoT and sensors will be important for creating these insights. But in the end, I think to make really successful projects, partnerships and implementations of any type of smart sensors is essential. So thank you very much for attention, and I hope you find this interesting. And let's open the floor for some questions. And
first question we got in is, what are the success criteria for successful implementation of smart sensors?
That's a really interesting question. I mean, I think one of the things that is really important for any type of digitalization process within the utilities is that there is enough people that are really involved in this from different sides of the organization, right? From IT, from OT, that there's an understanding of to really do this, we probably need to change the way we look at data, we look at our grids, and it's not about implementing technology just by itself, right? It's about the process, and I think that's for me the most important success criteria, to understand that process and then to implement that process in your own organization.
Who will lead the implementation of smart sensors in utilities?
Yeah, that's a good question, because that really depends where it I think it needs to have ambassadors at different levels, right? At an operational level, it needs to have ambassadors at a executive level, and really create this kind of leverage throughout the whole organization. If I look at, for example, Alliander, we had a very good ambassador, Danny, who was really pulling and making sure everybody was staying involved in this process, and you see the result. In the end, they did a full integration of it, but it really depended on people and the drive of these people internally and then also externally from us.
Yeah. So there's a human aspect of the implementation as well.
I think there's a large human aspect in this. Yeah, you're right.
Yeah. So what is the cost of smart sensor implementation?
That's a good question, and I always make a joke. I say, listen, if you play it well, it's for free, because there's so many benefits of it. It will, you will not see the initial investments if you see all the benefits coming back. That's a one-sided joke that I make, but it's actually true. It's actually true that if you can prevent one outage from happening, your investment will be paid for. So I think the business case in many cases is easy, and but again, we also assist in that, in making these business cases for our customers, and really looking at, are you working just on fault prevention, or do you really want to look at fault detection and localization? Really trying to diminish or the time of a fault taking place.
So you would consider this as an investment, among other things?
Yeah.
What will be the impact on utilities not implementing smart sensors?
Yeah, I think what I see in some of the countries is that they stay blind in the way that they don't know the actual status, and they will use legacy models to then predict and plan maintenance, which I think costs will be much higher. Operational costs will be much higher than if you start implementing some way of monitoring and understanding actual status, and helping you in one, preventing faults from happening, but on the other side also, by these insights, create a better way of investment planning, because everybody knows that at some point they have to do investments.
Do we have two last questions I would like to ask? Could you say something about challenges for monitoring undersea cables, which is quite a relevant topic in Norway at the time?
Yeah, I think one is the distances, right? I mean, these cables are long and don't have connections or joints where you could do any type of measurements, right? So this is really around the technology evolving into carrying more distance. So what we're doing now is, with our current technology, we can measure up to, say, 15 to 17 kilometers of cable. But a lot of times these undersea cables are much longer. So that's where the challenges are in really finding technologies and enhancing technologies to measure longer cables.
And the final question: how do you pinpoint the exact location of the fault before start digging upstream?
So what we do is that we, what I showed in one of the diagrams, is that we put our sensors on both sides of the cable, and the sensor actually does two things. Once it measures the partial discharge activity, but we also send out a pulse, a high frequency pulse through the cable. So the pulses are sent from both sides of the cable. And by knowing the propagation time of the cable, we then can understand where the signal exactly is coming, so we can pinpoint the exact location of that signal, that PD signal inside of the cable. So that is how we detect by 1% accuracy of cable length the actual position of that partial discharge or fault.
Okay. Thanks again for the interesting presentation, Jerome.
Thank you for having me, and I really appreciate this. And let me know if there's any questions coming from this. I'll be happy to answer it and share more information.
Yeah, and your contact information is in your LinkedIn profile.
Yes, and I will put it into the presentation as well, which you can share with the attendees.
Great, thank you. And today's producers has been Christian Østvik Økland and Tarjei Åkre Reite. I would like to draw your attention to the next webinar that will give an extended insight into our new pilot project, Maxgrim, that many of you already have heard of. In that webinar, 5 of the project partners will present their motivation, contribution, and expected results from participating in one of the most ambitious and interesting projects that has come out of the Norwegian grid business. And also, in collaboration with University of Oslo, we will host a seminar about the psychological aspects of the energy transition. The seminar is open for everyone and will also be hosted at the University in Oslo. If you would like to know more about us, visit our website at smartgrids.no and subscribe to our newsletter, and do follow us on LinkedIn. That's it for today.